Hello everybody. So before we go actually further, wanted to mention one thing. Container orchestration for Docker Compose. I think in the previous video I didn't make it quite clear why are we using Docker Compose. Docker Compose is basically a container orchestration tool that's very simple. In the previous videos you've probably seen I've go in more detailed the benefits of why better than the K8s. But yeah, the whole idea here is try to not run each of these apps as a single container like I've done in the previous some of the demos that you've seen me doing. But now we're actually trying to go more into like a container orchestration, because now we have like a multiple services, right? So we have API, we have a Grafana, we have Prometheus, we have vector database, we have a Ollama where we're serving our AI model. So AI model is here, vector database is here, Prometheus and Grafana, this is observability stack, and then we have our API where we make our request. So that's part of the reason I want to mention. The another thing is the vector database. The reason I want to mention quickly vector database is because if we don't have a vector database, what happens is that a lot of times AI models, they start hallucinating. And when the hallucinations become really bad, it's very, very sad that, it starts like throwing out very random information. And this is really bad because we wanted to make sure that our AI models are more responsible in their answers, right? And they give us answers, much more clear answers. And so this is part of the reason why we use vector databases. Vector databases is the information that we feed them. So and then the vector database gives that information to our AI, and then AI basically generates the latest information, combines it with whatever information it has. So how everything connects. So let's go to the next slide number 4, architecture. So client sends a request via API or curl. So we will use curl commands to do our requests. You guys will see, and then we will move slowly to the to the next portion of the app, stage by stage. FastAPI handles requests, applies security. Ollama runs LLM like Mistral. So first we send our curl request. Guys, you can use Postman too if you're a developer and you're more comfortable with the Postman, but I personally use curl, so that's why I've been using curl through the CLI command line. FastAPI handles requests, applies security. Ollama runs LLMs like Mistral, Gemma, Ollama, whatever model you supply. It basically downloads from the Ollama registry and then tries to run it out of there, right? So that's part of this right here. This is in Ollama.com. You will see all these different models, and whatever model you want to use, you can just pull it out. And then we have Chroma, stores embeddings and retrieves relevant context. Prometheus plus Grafana. So it's this part, Prometheus and Grafana, basically it tracks the performance and system health. So this is very important, right? So we wanted to make sure we have observability, where we basically have a Prometheus as a basically monitoring system that collects and stores metrics from various sources. And then basically feeds that to our Grafana. Grafana is basically a visualization tool that uses data from different data sources like Prometheus, and then basically gives us very nice dashboards. We will look into that shortly. Analyze data from different data sources, and this is part of the observability. What we want to make sure is that we have some kind of observability monitoring system that basically does that for us. One ecosystem where all components work together. So as I mentioned before, so if we go to API, this is the logs for the API, and then if we go to Grafana, this is the logs for the Grafana, and Grafana's container is running perfectly as well. Prometheus, we can see the Prometheus logs generate beautifully. We have everything in place. Chroma is working beautifully as well. We loaded some data into it, so we're gonna work with that data, and then we'll have our Ollama here serving our AI models. So going back to the next slide, slide number 5, Ollama model engine. So the reason I keep bringing these things up very quick is because it's it's repeating these things is much better, so that you can it gets stuck in our head, right? So that we can just kind of do a refresher. Ollama is the engine that runs different AI models locally, supports models like Mistral, Llama 2, DeepSeek, Gemma, and there's like a whole list of the different models that you can see here in Ollama.com. And there's a Granite by IBM, there's Gemma by Google, DeepSeek by DeepSeek, and there's Mistral by Mistral, Llama by Facebook. all these different models that you can use in your stack. Runs on CPU or GPU, it runs on both. So for example, if you don't have a GPU, then it still runs on CPU. That's totally fine. Private and portable, no external API required. In fact, we don't need some kind of like a Python app to hit the Ollama. We can just do that. I've already posted videos where I did with a Python app, but also I've done it just through the Nginx as a reverse proxy, just hit the Ollama straight, the Ollama service. This means you can test multiple models easily and switch between them without rebuilding your app. So yes, you don't have to rebuild your app. You can just switch it really quick and then just on the fly, just change the model and then just do it. All right, so I'm gonna stop here and then we're gonna meet for the part 3. I don't want to make these videos too long. So see you later.